time class case study, creating packages. Throughout the many examples that we've demonstrated to you in this video course, one of the things that you've seen is that we've been reusing built-in classes of the Java class library. And sometimes when we needed to use those classes, we were required to use an import declaration, and sometimes we were not. In the cases where we were not, the classes we were using, things like system and string and integer, were part of the so-called java.lang package, which is automatically imported into every Java application, or actually every Java program you create. Those classes are considered to be so fundamental to Java, they don't require you to import that particular package. But for all other packages from the Java class libraries or from any third party that you might download or buy a package from, you're going to need import declarations. Now separately, we did a lot of creating our own classes, and we had many multiple source file programs in which we never needed to import our own classes for use in those programs. And the reason for that is all of our programs so far have been basically self-contained. All the .java files and all the .class files were wrapped into one folder, and remember that when you have multiple classes compiled into one folder, those classes are considered to be part of the same so-called default package. And when you have them in the same default package, all of the classes automatically know about one another, so you can simply go ahead and use them without ever having to say, I'm going to import classes into my program for use. Well, now what we want to focus on is the possibility of creating your own reusable packages. For example, you may create a whole bunch of classes that are useful in multiple projects within your company or within your university, and in that case, you would probably want to package those up to not only put related classes into the same package, but also to make it so that other people who need to program with those classes can import them into their code rather than having to copy all of the code into their applications. So our goal here is to create a truly reusable class or set of classes. And we have a number of steps that we need to perform to create a reusable class. The first step is that we have to declare a public class. So almost all of the classes we've defined so far have been public classes. In fact, there was only one example in which we happened to have two classes in the same file that we had one of those classes not be declared public. And the reason in that case was because only one class per file can be public, and that's because whatever type you define as public in a given source code file in Java, the name of the file must be the same as the name of the type plus the .java extension. And that applies to enumerated types, classes, and another category of type that we don't cover in this video course called interfaces. We discuss interfaces in detail in the second course in this sequence. In addition to making a class public, we also, one other thing about that, sorry. When a class is not public, it has what we call package access, meaning that all of the classes within the package know about that non-public class, and the class is usually there to support the other classes. However, if you were to wrap up all of your classes, including the non-public ones, into a package for redistribution, the client code that uses classes from your package will only be able to use the public classes within that package. All right, so now the question is, how do we go about creating a package? And the key thing we need to do is add a package declaration to our source code file. So the package keyword starts a package declaration, and a package declaration must be the very first line of code inside your source code file. The only thing that can appear before a package declaration are comments and possibly white space, blank lines, for example. So the very first thing in the file is the package statement. If you have import declarations, they would come next, and then finally your type definitions would come after that. Normally there's one type definition per file, but as we showed you earlier in this lesson, it is possible to have more than one type definition in a file as long as only one of them is public. So we're going to talk about creating a package statement, and there are some naming conventions that you're supposed to follow for package statements, starting with the beginning of the package name. Usually, you're going to use either your company's domain name, your educational institution's domain name, your government organization's domain name in reverse to start the package name. And one of our goals here is to make sure that every single class we ever create is uniquely named, so that if by any chance somebody using your code imports one of your classes and happens to import another class with the same name from a different package, there's a way to distinguish between those classes. And the reason for that is the package name becomes part of the class name. So if everybody at least starts out by taking their institution's domain name and reversing it, that helps us to uniquely name our classes. So for us, when we create packages, we tend to start their names with com.ditel because our website's domain name is ditel.com. After the first two names there, it's really kind of up to you what you're going to use. For us, we always use an encoding of which edition of Java How to Program we're dealing with. So this is the 7th edition of Java How to Program, so we said JHTP7 for Java How to Program 7th edition. If you were to go back and look at the prior 6 editions, you'll see in each case that we used a different encoding for this third name. And then as a fourth name in all of our packages, we also use the chapter number in which the class can be found. And the reason we do this is if we were to reuse one of our classes in a later example, we want somebody, by looking at the import declaration, to be able to say, oh, I know where to find that in the book. It's in chapter 8. Let me go back and look there. So our package name is going to be com.ditel.jhtp7.ch08 in the example that we're about to show you. Now, the package name becomes part of the class's so-called fully qualified class name. So if I'm going to take my Time 1 class from the beginning of this chapter, for example, and turn it into a reusable class, and use this as my package name, com.ditel.jhtp7.ch08, my new class name is actually all of these names from the package with all the dots that you see here, followed by another dot and my class name. And I can actually write that everywhere I need to use class time 1 throughout my code, but obviously that's a bit of an inconvenience. What I've found is that a lot of code generation tools tend to use fully qualified class names, but most Java programmers tend to use import declarations so that they can use the so-called simple name of the class in their code, and the simple name is just the class name by itself. The next step in dealing with a reusable class is to make sure that you compile the class correctly so that the .class file is placed into the proper package directory structure. So when you actually compile a class that's in the package com.ditel.jhtp7.ch08, the .class file will be in a nested directory structure starting with com, having a subdirectory called ditel, which contains another subdirectory called jhtp7 and another subdirectory called ch08. Inside of that ch08 folder is where you would find the .class file that represents your compiled class definition. Now, in order to do that, we have to use a special command line option to the Java C compiler. The -d option is how you specify the directory in which you would like the package directory structure to be placed. So you specify that as the starting point, and then the compiler will either look for your package directory structure in there, and this would be if you were compiling a bunch of individual classes that are all part of the same package, you'd keep directing them to the same location on disk. Or if the folders don't exist yet, it will actually go into the folder you specify and create the complete package nested directory structure for you automatically. Now, we're going to show you how to do this from the command line after we look at our source code. But the other thing is that tools like NetBeans and Eclipse and other Java development environments tend to manage the concept of packages completely for you so that you don't have to worry about issues like this. In fact, in NetBeans, what it does is it maintains a source code directory structure that includes all the directories for the package, and then it maintains a parallel directory structure containing all the corresponding .class files. And depending on which view you're using in NetBeans, you can look at that or you can just ignore that and it will just manage the package statements statements for you. It's even smart enough, if you rename a package, to recreate the directory structure for you using a technique called refactoring, where it reorganizes the code for you. Refactoring is a very interesting concept, and a lot of program development tools nowadays provide refactoring tools that help you do simple things like renaming code, such as variables or method definitions or class definitions. In Java, renaming package declarations, or possibly even doing things as complex as factoring out chunks of code that are repeated multiple times and turning them into a method definition. So once we've created a public class, incorporated a package statement, and compiled the class properly, the next step is to import our reusable class into a program so that we can actually use it. And there's two different ways to do that. There's a single type import declaration in which you specify an individual class that you'd like to import. For example, here we say import java.util.random, saying we'd like to import the random class from the java.util package. And then there's the so-called type import on demand style declaration, where you simply say at the end of the package name .*, and the compiler figures out which classes in your code have come from that particular package. So you have a choice as to how you want to import your classes. We prefer to use the single type import declarations, especially in our books, because it's also a form of documentation saying explicitly which classes we happen to be using in a particular source code file. But many programmers prefer the asterisk type import on demand declaration because it's convenient and they don't have to have multiple different import declarations for the same package. So now that we've gone ahead and specified an import declaration, the next step would be to compile the class that's going to use the imported class. And there's a special piece called the class loader that's used both at compile time and at execution time that locates classes the compiler needs or locates classes that the runtime needs, so that in the case of the compiler it can load those classes and make sure we're using them correctly, and in the case of the runtime it can load those classes so we can actually make use of them in the execution of our application. So the way it works for the compiler is that it locates all the classes that the compiler needs, first by searching through the Java classes that are bundled with the Java development kit, and then searching through what are called optional packages. Java actually provides an extensions mechanism where you can drop new packages of classes into a specific folder, and those will automatically extend your Java development kit or your Java runtime environment so that those classes can be used in your runtime and at compilation time as well. And then finally, it searches in something called the class path. Now, the class path is basically just a list of directories in which you can find additional classes. It could be individual .class files in those directories. It could be .jar files, which stands for Java archive file, or .zip files, which are zip archive files. In fact, the underlying structure of a jar file is the same as the underlying structure of a zip file. And in fact, all of the Java classes that are built into the Java runtime are located in a file called rt.jar that gets loaded by the Java runtime. So you can actually package up your classes into these archive files and place them into what is known as the class path. Now, the class path can be specified a couple of different ways. One way to specify the class path is with the -class path option to either the Java compiler or the Java runtime. And the other way is to use this so-called class path environment variable. Now, the class path environment variable is actually dangerous and causes all sorts of problems for the people that are reading various Java books and learning Java out there. Some programs actually install a class path. For example, I believe the Apple QuickTime installs a class path because I believe QuickTime uses some Java. And the problem with it is that the class path that it installs does not include looking in the current folder. And obviously all of the programs that we've done so far up until this point, we had the classes in the current folder that we were defining. So if the class path doesn't include the current folder, then when you try to run your program, it tells you can't find your classes, even though you're in the right folder and the class files are right there in front of you and you can see them in your directory listing. So it's actually a good idea not to set the class path. But if you do have a class path environment variable, all you need to do to make sure that it works correctly with the classes in your local folders is to place at the beginning of its value a dot followed by a semicolon, and make sure there's no spaces on either side of the dots and the semicolons that you're placing in. So again, place a dot and a semicolon at the beginning of your class path, and that will make your local directory classes part of the class path as well. Now, the better way to deal with the class path is to use the -classpath option to either the Java compiler or to the Java command for running your program. When you use it with the Java compiler, after a space, you can list out a bunch of directories separated by semicolons, and the compiler will automatically look in all of those directories for classes that it needs to use for compilation purposes. And similarly, the Java runtime environment, which a lot of people refer to simply as the JVM, the Java Virtual Machine, the Java runtime environment also can use the class path to locate files so that it can load them for running purposes.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons, self-paced personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.